Hydrogen, the smallest atom, yet one of the most significant in the grand tapestry of the cosmos. It is the most abundant element in the universe, making up roughly 75% of its elemental mass. Its story begins moments after the Big Bang, the colossal event that birthed our cosmos approximately 13.8 billion years ago. In that unimaginably hot and dense soup of primordial energy, the very first element emerged, hydrogen, the simplest and most fundamental building block of matter. The early universe was a chaotic sea of elementary particles, a cosmic dance of creation and annihilation. Among these particles were protons, the positively charged building blocks of atomic nuclei. Neutrons, their neutral partners in the nucleus, were also present, playing a crucial role in the stability of atoms. And then there were electrons, those tiny, negatively charged particles that dance around the nucleus, creating the atoms we know today. As the universe cooled over time, protons and electrons began to combine, forming the first simple atoms. They formed the simplest atom, hydrogen, a single proton orbited by a single electron. This marked a pivotal moment in the universe's evolution, setting the stage for the formation of more complex elements and structures. Hydrogen, the simplest and most abundant element, became the building block of everything we see around us. From the stars that light up the night sky to the water that sustains life on Earth. From the blazing stars that illuminate the cosmos to the water molecules that are essential for life, hydrogen is the common thread that connects us all. This is just the beginning of the hydrogen saga, a tale that unfolds across billions of years and encompasses the vastness of the universe, from the smallest atom to the largest galaxies. From the heart of stars where hydrogen fuses to form heavier elements, to the laboratories on Earth where scientists explore its potential, hydrogen's journey is brimming with wonder, power, and the promise of a sustainable future. Let's delve deeper into this fascinating story, exploring the many roles hydrogen plays in the universe and its potential to shape our future. Vast clouds of hydrogen, remnants of the Big Bang, drift through the cosmos. These clouds, seemingly tranquil and serene, are the building blocks of the universe, floating through the vast expanse of space, waiting for the right conditions to ignite a cosmic transformation. These are not just random clouds, they are stellar nurseries, the birthplaces of stars. Within these regions, the delicate dance of cosmic forces begins, setting the stage for the creation of new stars. The Hubble telescope has captured breathtaking images of these nurseries, revealing the intricate beauty and complexity of star formation. Gravity, the architect of the universe, draws these hydrogen atoms together. This invisible force, ever present and relentless, pulls the atoms closer, initiating a process that will eventually lead to the birth of a star. The gravitational pull is the unseen hand that sculpts the cosmos, shaping the destiny of these hydrogen clouds. As the cloud collapses under its own gravity, the hydrogen atoms at the center collide with increasing speed and frequency. This collapse is a critical phase, where the cloud's density and temperature rise dramatically. The once diffuse cloud becomes a hotbed of activity, with atoms crashing into each other, generating immense energy. These collisions generate heat, immense heat. The temperature within the collapsing cloud skyrockets, creating regions of intense thermal energy. This heat is a precursor to the next monumental step in star formation, setting the stage for nuclear reactions to occur. The temperature at the core of the collapsing cloud soars, reaching millions of degrees. At these extreme temperatures, the environment becomes ripe for nuclear fusion, the process that will ultimately give birth to a new star. The core, now a cauldron of searing heat, is on the brink of a transformative event. This intense heat and pressure overcome the electrostatic repulsion between the positively charged protons in hydrogen nuclei. The protons, which would normally repel each other, are forced together by the overwhelming conditions at the core. This overcoming of repulsion is a pivotal moment, allowing the fusion process to commence. They are forced to fuse. This fusion of hydrogen nuclei marks the birth of a star, a process that releases an incredible amount of energy. The fusion reaction is the heart of the star, driving its luminosity and heat. This process, nuclear fusion, is the engine that powers the stars. It is the fundamental mechanism that fuels the brilliance of stars, converting hydrogen into helium and releasing energy that radiates across the universe. In the intense heat and pressure of a star's core, hydrogen atoms fuse to form helium, releasing tremendous amounts of energy in the process. This energy is what makes stars shine so brightly, illuminating the cosmos and providing warmth to any surrounding planets. This energy radiates outward, counteracting the inward pull of gravity and creating a delicate balance that keeps the star stable for billions of years. This equilibrium is crucial for the star's longevity, allowing it to burn steadily and provide a consistent source of light and heat. Our very own sun, a giant ball of mostly hydrogen, shines because of this process. The sun's core is a continuous fusion reactor, converting hydrogen into helium and emitting the energy that sustains life on Earth. For billions of years, it has been converting hydrogen to helium in its core, bathing our planet in light and warmth. This process is the reason we have daylight, the changing seasons, and the energy necessary for life to thrive, and it will continue to do so for billions more. The sun's stable fusion process ensures that it will remain a reliable source of energy for the foreseeable future, supporting life on Earth and maintaining the delicate balance of our solar system. The stars we see twinkling in the night sky are all powered by the same process, the fusion of hydrogen. Each star, a distant sun, undergoes the same nuclear reactions, contributing to the vast and dynamic tapestry of the universe. It is the fundamental process that drives the evolution of the universe. From the birth of stars to the formation of galaxies, nuclear fusion is the engine behind the cosmic dance, shaping the universe as we know it and igniting the stars that light up our night sky. While hydrogen was busy igniting stars and shaping galaxies, it was performing a cosmic dance, creating the very fabric of the universe. This simplest and most abundant element in the cosmos has been a silent architect, orchestrating the birth of stars and the formation of galaxies for billions of years. Down on Earth, its presence went unnoticed for millennia. The ancient landscapes and prehistoric scenes were rich with hydrogen, yet humanity remained oblivious to its existence. It was a hidden force, quietly influencing the natural world. It wasn't until the 16th century that humans began to unlock the secrets of this elusive element. The alchemists of the time, with their rudimentary tools and mystical manuscripts, were on the brink of a monumental discovery. Paracelsus, a Swiss alchemist, unknowingly produced hydrogen by reacting metals with acids. His experiments were groundbreaking, yet he did not realize the significance of the flammable gas he had created. He observed the flammable gas produced, but didn't identify it as a distinct element. The mysterious gas was a puzzle piece in the grand scheme of chemistry, waiting to be properly identified and understood. Fast forward to the 18th century, a period of enlightenment and scientific revolution. The world was ready for new discoveries, and the stage was set for hydrogen to be unveiled. English scientist Henry Cavendish finally isolated hydrogen. His meticulous experiments and keen observations led to a breakthrough that would change the course of science. He conducted an experiment, reacting zinc with acid, and collected the gas produced. This was a pivotal moment, as Cavendish was able to isolate and study the properties of hydrogen in a controlled environment. Cavendish called it inflammable air because of its ability to burn readily. This characteristic made hydrogen both fascinating and dangerous, capturing the imagination of scientists and alchemists alike. However, it was French chemist Antoine Lavoisier who, after repeating Cavendish's experiment and conducting further studies, gave the element its official name, hydrogen. Lavoisier's work was meticulous, and his contributions to chemistry were profound. Lavoisier recognized that this inflammable air combined with oxygen to form water, a groundbreaking discovery. This revelation was a cornerstone in the field of chemistry, providing a deeper understanding of the elements and their interactions. He coined the term hydrogen, derived from the Greek words hydro, water, and genes, forming, perfectly capturing its essence as the element that forms water. This naming was not just a scientific formality, but a reflection of the element's fundamental role in nature. The discovery of hydrogen marked a turning point in our understanding of the universe and our place in it. It was a moment of enlightenment, opening new pathways for scientific exploration and discovery. It revealed a fundamental building block of the cosmos, an element that not only fuels the stars but also plays a vital role in the existence of life on Earth. From powering the sun to being a key component of water, hydrogen is integral to life as we know it. Its discovery has had far-reaching implications, influencing everything from energy production to our understanding of the universe. Section 4. Hydrogen's terrestrial forms. While hydrogen is the most abundant element in the universe, it exists on Earth primarily in a bound state. It readily combines with other elements to form a wide variety of compounds. Water, the most ubiquitous example, is formed when hydrogen bonds with oxygen. Hydrogen is also a key component of hydrocarbons, compounds consisting of hydrogen and carbon. Hydrocarbons are the building blocks of fossil fuels like natural gas, oil, and coal. These fuels have been our primary source of energy for centuries. Beyond fossil fuels, hydrogen is found in a myriad of other compounds essential for life. It is a component of carbohydrates, fats, proteins, and nucleic acids, the fundamental building blocks of life. Even though pure hydrogen gas is not naturally abundant in Earth's atmosphere, its presence in these various forms highlights its importance in our planet's chemistry and our own existence. It is a testament to hydrogen's versatility, its ability to bond with a wide range of elements and form compounds with vastly different properties. Section 5. The power of hydrogen applications on Earth. Since its discovery, we have found ingenious ways to harness hydrogen's power. It fuels rockets, propelling us into space. It powers fuel cells, offering a cleaner alternative to fossil fuels. One of the most promising applications of hydrogen is in fuel cells. Fuel cells are electrochemical devices that convert the chemical energy of hydrogen and oxygen directly into electricity, with water as the only byproduct. Fuel cells offer a clean and efficient alternative to traditional combustion engines, holding great potential for transportation and other applications. Hydrogen is also crucial in various industrial processes. The Haber-Bosch process, for example, uses hydrogen to convert nitrogen from the air into ammonia. This ammonia is then used to produce fertilizers that are essential for modern agriculture. From powering rockets to producing fertilizers, hydrogen plays a vital role in our modern world. As we move towards a more sustainable future, hydrogen's importance is only going to increase. Its versatility and potential to provide clean energy make it a key player in the transition to a greener planet.